So let's see how we are going to use the predictive analysis. So I just created a small presentation and we will walk you through the fundamentals of predictive analysis using the decision trees. It's an exciting topic and we are using machine learning for learning this. Understand first what decision trees are all about. As you can see here, you will see some nodes and then finally you will see some colored leaf nodes, and those colored leaf nodes are nothing but the decisions which are coming as a result of our decision tree. Nodes will be connected to other nodes and there are edges. The edges will have the conditions, and based upon the conditions you will go from the root node to the subsequent node and then finally to the leaf nodes. The selection of the root node is the most complex thing here, and for that let us take this particular sample. On the top of this you will see that there is a table which is telling about the statistics of some players who played golf on some attributes like temperature, outlook, humidity, windy, etc. And on various days, those conditions are being tracked and it is being added into this particular table, and this table will be used as the training data for our decision trees. So this is the next fundamental information, that for a decision tree to work properly, you need to have some training data by which decision trees will understand something from that training data, and then you can use some questions for today and tomorrow, as you can see in the last part of this particular screen. So will I play tomorrow? Given the weather broadcast is telling me the attributes are having mild, sunny, normal and false values, will I be able to play it or not is the question. And using the decision trees and the predictive analytics algorithms, we will be able to tell whether we can play or not. And you extend this particular example to any of the available prediction related things in the market. For example, you might be looking at some of the customers' reaction on some of the products in a retail shop with some attributes. And once you have the training data, you can use it. So as I told you, the most complex thing in the decision trees is selection of the root. So here you can see that outlook is one root, temperature is another root, windy, humidity, etc. are other roots. You can start with a root and then you can come down, traverse down to a leaf node to take your decision. But what will be your root? To answer that question, we need to run some algorithms, and these algorithms are some very famous algorithms existing in the machine learning industry from years before. And please don't think that these are all the technologies that came up along with big data. No, far before big data, these were existing. One such algorithm is by Ross Quinlan's ID3 algorithm, and that ID3 algorithm is also called as iterative dichotomizer 3 algorithm. And he himself, Ross Quinlan, modified that algorithm and called it as C4.5 algorithm at a later point of time. And there was a proprietary algorithm. Some vendor has bought it. So what the Java people did is they created an equivalent J48 algorithm instead of C4.5. In fact, it is a derivation of C4.5, and we are going to use that J45 algorithm in our example in order to predict what will be the result. And all these machine learning algorithms are going to use two variables. One is called entropy and another is called information gain. Based upon these two, you will be calculating what is the best route that should be selected for decision tree. So the fundamental question for any decision tree based analytics is the selection of the route, the entropy, information gain, along with the algorithm J48, which is a derivative of C4.5, will help you to design what decision tree you should be using. So the final decision tree after applying the relevant algorithms is shown here. And as you can see, Outlook is chosen as a route. And please look at the final result. If you observe, the final result is going to be yes, which means that tomorrow I will be playing. So basically what I did is that we predicted what could be the scenario for tomorrow based upon the training that decision tree had received on the input data that had been provided. The more the input data, the accuracy and precision of the result will be better. So basically, you will be taking some data from the existing clients on the existing industries, and then you will be feeding it as input to the decision tree, and from there you will take it forward, calculating the entropy and the information gain, and then finally you will be coming up with the result. So without much ado, I am now going to take a Word document in which I showed you how that left hand side is translated into the right hand side using entropy, and you will see some logarithmic formulas here to calculate entropy. Don't worry too much about it, we can discuss it in detail later. And you can see that I am calculating the information gain by applying some formulas there in terms of entropy and the information gain, and finally I get something called a gain. And once I get this gain value, the next part is to check which variable is giving me highest gain, whether it is temperature, whether it is humidity, or whether it is Outlook. And in this example, Outlook has given me the highest gain. That's the reason why we used Outlook as the starting point of our decision tree. In similar scenarios, we will be applying this formula to the number of variables, and then we will be calculating the gains on each occasions, and then the variable or the attribute with the highest gain will be used as a route for your decision tree, and then the decision tree will be formed. And it is almost common that every 6 months you will revisit this particular case by training the decision tree with more and more data, so that your model gets changed at some times. So this is the fundamental idea behind the usage of decision trees. It is used very widely in the industry for driving decisions based upon the input values. And now I will show you a tool which automatically does all these things for you without calculating or bothering about entropy or information gain. So let's start. I am going to start a particular tool called Waka, which is developed by the University of Calcutta, and Waka is showing you some options when you start it, and I am going to click on the first option called Explorer. And once I have the Explorer opened, next is to take my input file. Please look at my input files. I took this input file from a library, and I asked the librarian that what is the rate at which the books are being borrowed by certain individuals, looking at some of the fields that you see here, like placement, prominence, pricing, eye level, etc. For example, if somebody is placing a book in computer books rack, with the prominence of say 80 to 85, where the pricing is large, it's a costly book, and eye level, whether the customer can see the book directly or not, that will derive my borrowed status. So you can see that some borrowed status are yes and some borrowed status is no, etc. Right? And this is sample data which is being created by taking a real life scenario from a library. So you got your data file, and that's the fundamental input that is needed for any decision tree based analysis. So once you have this particular data, the next step is you will have to go back to your tool, which I have just opened, namely the Waker tool. And in the Waker tool, you are going to click on the option to select the file called Open the File. And please select the file you have just seen now, and that will be your sample input file, right? So it is kept in a directory and it is a comma separated value file, and I selected that particular file. And after selecting that file, what you need to do is you have to go back to your Waker. So just to hold on for a moment, I selected the file here, and now you click on open, right? And the moment you open, you see the Waker tool has shown you all the attributes that have been used in that particular input file: placement, prominence, pricing, eye level, borrowed status, etc. It also shows what are the conditions by which you derived the results, final borrowed status as well. Right? And this is a salient feature by the Waker tool. And now I'm going to click on classifier, and then I select the algorithm that is to be used. So under trees, you will see many algorithms there. We will see each of them later. And you selected J48 algorithm. And after applying the J48 algorithm, click on Start, which quickly calculates the entropy, information gain, all the variables that I had discussed just now, without even writing a single line by yourself, and then finally creating the decision tree. But I'm not interested in seeing this data like nodes or the typed test. So let us click on the visualize tree. And the moment you click on the visualize tree, and then just I'm making it bigger enough so that you can see it clearly, you will see that the tree is created, and you can see placement is selected as the root. So please take some time and then calculate the entropy and the information gain, and you will see finally that placement is a good option. So if suppose tomorrow that library is getting a book, they can easily use this decision tree to decide whether they should keep the book on a computer books rack, reading room book rack, or the front side rack, and what are the conditions by which each are being governed. So basically what you did is, by looking at some sample data and by using the J48 algorithm, you created a decision tree which will drive your result on selecting a book and then placing it at a place where the borrowers can get benefited. Apply this particular theory to anything and everything where you have some sample data, and we at PassionBytes can take this sample data, generate an algorithm for you, and then we can use the decision tree, which is the result of that algorithm, to predict what would be better. Now I'm showing you something more. I want to generate some code, because if you look at the last part of this, you can see that there's a confusion matrix, right? And now what I'm going to do is that I will enable an option called output the source code, and then click OK. And after that, I will start again, and you see the last part now. It is not the confusion matrix, but instead it is a Java program. And you can see that it has written a Waker wrapper. The Waker wrapper is the Java code behind the decision tree that you have just seen now. And what I can do with this code, I can take this code and put it on the top of a Hadoop file system as a MapReduce program. And then I can apply this particular program onto the new data and decide whether a new book should be placed on a computer rack or on a front side rack or on a reading room rack. That's the beauty of analytics when combined with big data. Thank you and talk to you later. Bye-bye.